So in this video, we're just going to go over a basic speed and velocity sheet that I believe you have a copy of. You should have a copy of this. So we're just going to go over it, and we're just going to go over the general way to do the questions. It's not about giving the answers, just the basic way to do the questions. It's a pretty straightforward speed and velocity sheet. So we're the first question here, basic graphs. We started looking at speed and velocity by looking at DT graphs. So it's a basic DT graph type question. Of course, it's asking for the speed of the car. Of course, the speed of the car is the slope on a DT graph. It's a nice straight line, so it's really, really simple. So you want the slope of the graph. And of course, that's rise over run, delta y over delta x, however you want to look at it. But of course, for this, it would be the delta d over the delta t. Of course, we typically just write it as these, the change in distance over change in time, or d over t, whichever you prefer. And basically just looking for the slope of the graph. And it's kind of an idealized point. We can say it goes up to 12 and it goes across to 3. So I'll let you, take the best reading that you can. When you're all done, I'm not going to do the full solution for you guys. So when you're all done, you should get about around 4 meters per second when you're all done. So it's pretty straightforward question for that one. Okay. Number 2 is a similar type of thing involving a graph. We're looking for the average speed of the graph. We're looking for the average velocity of the graph. Our speed and velocity are similar but different. Speed uses distance and velocity uses displacement. So, either way, if you want the average speed for the graph, of course, you'd want to use the total distance, and you'd want to use the total time for those two things. So you got to look at the graph, and you got to look at how far it went during the first part, how far it went during the second part, add those distances together. The total time is relatively simple, but since it is going up and then down, you got to take the distance up, the distance down. You got to put those distances together to get the total distance, and then divide by the total time. And if you do that, you should hopefully get around 3.5 meters per second when you're all done for that one. Now for the velocity, it's similar but different, and I typically write my average velocity like this. You want the displacement of the time, so you want to go from beginning to end. So where did you start and where did you end? And it's not about what's happening in between, it's about beginning and end. The time is the same, but you want displacement, not the distance. And if you analyze this carefully and do sort of what we're working on, hopefully you'll get a negative 0.5 meters per second when you're all done. Okay. The next question, I got a little pug running here. How long would it take for a dog to go across a field of 6.8 meters per second? Case one for time. So it's basically, time is distance over v. It's a constant v, so it's nice and simple. Basic application, and hopefully when you're all done, hopefully you'll get around 11 seconds. Okay. For the car, a little Lego car here. First thing, you got to convert that. You got to convert that to meters per second. You got kilometers an hour, you've got the seconds. When in doubt, everything in meters per second is the best way to go. If the 18 had been in hours, kilometers would have been fine. You wouldn't have to change anything. But when you've got the mixed units, you typically want to switch it up, and meters and seconds is the best thing to go to. So for this one, how far did you go? Well, that's basic, just basic DTV is what that is. You have the time, convert the speed, and when you're all done, hopefully you'll get around 700 meters when it's all done. Okay. Number 5, what's your speed if you go 723.5? Again, you got to convert this, convert that into seconds, and then you're looking for the speed. Of course, speed is distance over time. You've got the distance already. Convert the time, divide the two out. Relatively straightforward, and hopefully you'll get around 3.4 meters per second. Okay, and the last one, you move it 16 for 8.5. What velocity we need to get back at 5.3? Well, there's two parts to this setup. What you can do is you can use this v and this t to get the distance that you actually went. And then what you can do is use that distance and the new time in order to find your new second v. So it's dtv and then dtv again. You can find the distance that you went using the first speed and the first time, and then use that distance with the second time to find your second speed. And it is velocity, so since you're coming back, it should technically be negative. So hopefully you'll end up with negative 26 meters per second when you're all done. Okay, so that's basically how to do these questions. Again, you know, I give you the starting point and sort of what you should end up with, and you should be able to figure out those middle parts on your own.